Good morning, everybody. Welcome to my channel Proper Guidance. This is a channel to guide you for CBSE Board Computer Science Class 11. Here we are now discuss about the chapter number 3 CBSE Board Class 11 Computer Science. I have already discussed chapter number 1 and 2 in my previous videos, and chapter number 3 was also started but yet to complete. Today I will complete this chapter. The first topic for today's chapter is sensors. Now, what do you mean by sensor? What is sensor? Suppose you are using your mobile phone, and as you hold your mobile, suppose you are holding it vertically or horizontally, right? The display also changes to vertical or horizontal with respect to the way we hold our mobile. This is possible with the help of two sensors. This is not a magic, right? Here is no magic here. This is possible with the help of two sensors only, namely accelerometer and gyroscope. This is very important. You have to know about these sensors, right? The sensors are very important part. What is a sensor? And accelerometer and gyroscope, these two sections, these two sensors, namely accelerometer and gyroscope, right? The accelerometer sensor in the mobile phones detects the orientation of the phone, and the gyroscope sensors tracks rotation or twist of your hand and add to the information supplied by the accelerometer. Sensors are very commonly used as monitoring and observing elements in real world applications. The evolution of smart electronic sensors is contributing in a large way to the evolution of IoT. It will lead to creation of new sensor based intelligent systems. A smart sensor is a device that takes input from the physical environment and uses built in computing resources to perform predefined functions upon detection of specific input and then process data before passing it on. Then, this is all about sensor. I think you can understand what is sensor. Please go through the entire topic here, and then we will discuss about smart city. Okay, with rapid urbanization, the load on our cities are increasing day by day, and there are challenges in management of resources like land, water, waste, air pollution, health and sanitation, traffic congestions, public safety and security. Besides, overall city infrastructures including road, rail, bridge, electricity, subways, disaster management, sports facilities, etc. These challenges are forcing many city planners around the world to look for smarter ways to manage them and make cities sustainable and livable. See, here is a picture about smart city. Can you see it? Okay. The idea of a smart city as shown in this figure makes use of computer and communication technology along with IoT to manage and distribute resources efficiently. The smart building shown here uses sensors to detect earthquake tremors and then warn nearby buildings so that they can prepare themselves accordingly. The smart bridge uses wireless sensors to detect any loose bolt, cable, or crack. It alerts concerned authorities through SMS. The smart tunnel also uses wireless sensors to detect any leakage or congestion in the tunnel. This information can be sent as wireless signals across the network or sensor nodes to a centralized computer for further analysis. Every sphere of life in a city, like transportation system, power plants, water supply networks, waste management, law information systems, schools, libraries, hospitals, and other community services work in unison to optimize the efficiency of city operations and services. So, these all things are common to us in today's world, right? Smart cities and uh, near future we will just live in this type of society, this type of city will be here, just like today's smartphone. We will live in a smart city also, right? Now the most important topic of this chapter is cloud computing. This is very important. Cloud computing. Now, see here cloud computing. What is cloud computing? Cloud computing is an emerging trend in the field of information technology where computer based services are delivered over the internet or the cloud, and it is accessible to the user from anywhere using any device. This is the vital point. Please note it down. Cloud computing is an emerging trend. Why? Because it is accessible to the user from anywhere using any device. The services comprise software, hardware, databases, storage, etc. These resources is provided by companies called cloud service providers and usually charge on a pay-per-use basis like the way we pay for electricity usage. We already use cloud services while storing our pictures and files as backup on internet or host a website on the internet. Through cloud computing, a user can run a bigger application or process a large amount of data without having the required storage or processing power on their personal computer as long as they are connected to the internet. Besides other numerous features, cloud computing offers cost effective on demand resources. A user can avail need based resources from the cloud at a very reasonable cost. So, this will be a, an advantage to us, right? Now here we see what are the cloud services we can get, right? Here is a picture, can you see? Servers, laptops, phones, tablets, desktops, and software as a service, platform as a service, infrastructure as a service. These are the services offered by cloud computing. We are served with this type of services. Now see, a better way to understand the cloud is to interpret everything as a service. A service corresponds to any facility provided by the cloud. There are three standard models to categorize different computing services delivered through cloud as shown in the picture. In this picture, these are infrastructure as a service, platform as a service, and software as a service. Now we will discuss elaborately. First, infrastructure as a service. The infrastructure as a service providers can offer different kinds of computing infrastructure such as servers, virtual machines, storage and backup facility, network components, operating systems, or any other hardware or software. Using this kind of facilities from the cloud, a user can use the hardware infrastructure located at a remote location to configure, deploy, and execute any software application on that cloud infrastructure. They can outsource the hardware and software on a demand basis and pay as per the usage. Thereby, they can save the cost of software, hardware, and other infrastructures as well as the cost of setting up, maintenance, and security. Next, platform as a service. The facility provided by the cloud where a user can install and execute an application without worrying about the underlying infrastructure and their setup. That is, this kind of facility provides a platform or environment to develop, test, and deliver software applications. Suppose we have developed a web application using MySQL and Python. To run this application online, we can avail a pre-configured Apache server from cloud having MySQL and Python pre-installed. Thus, we are not required to install MySQL and Python on the cloud, nor do we need to configure the web server, right? In this system, the user has complete control over the deployed application and its configuration. It provides a deployment environment for developers at a much reduced cost, lessening the complexity of buying and managing the underlying hardware and software, right? Then, software as a service. The last one. Software as a service provides on demand access to application software, usually requiring a licensing or subscription by the user. While using Google Doc, Microsoft Office 365, Dropbox, etc., to edit a document online, we use this kind of service from cloud. A user is not concerned about installation or configuration of the software application as long as the required software is accessible. Like this one, the previous one, a user is provided access to the required configuration settings of the application software that they are using at present. In all of the above standard service models, the user can use on demand infrastructure or platform or software and is usually charged as per usage, thereby eliminating the need of a huge investment upfront for a new or evolving organization. In order to utilize and harness the benefits of cloud computing, Government of India has embarked upon an ambitious initiative, GI Cloud, which has been named as Meghraj. Okay, Cloud Meghraj. And now I think this is clear to you. You people just go through all these 3 points. Three standard model for cloud services. This is very basic concept will be needed for your syllabus. You just go through, right? Mm, And then come grid computing. This is another important topic in your syllabus. A grid is a computer network of geographically dispersed and heterogeneous computational resources as shown in the figure. Unlike cloud, whose primary focus is to provide services, a grid is more application specific and creates a sense of a virtual supercomputer with an enormous processing power and storage. The constituent resources are called nodes. These different nodes temporarily come together to solve a single large task and to reach a common goal. Nowadays, countless computational nodes ranging from handheld mobile devices to personal computers and workstations are connected to LAN or internet. Therefore, it is economically feasible to reuse and utilize the resources like memory as well as processing power. The grid provides an opportunity to solve computationally intense scientific and research problems without actually procuring a costly hardware. Grid can be up to types, data grid and CPU or processor grid. Now, first one is data grid. What is data grid? Right? Look at this data grid. Data grid. See here, data grid. Data grid used to manage large and distributed data having required multi-user access, and CPU or processor grid where processing is moved from one PC to another as needed, or a large task is divided into subtasks and divided to various nodes or parallel processing. Grid computing is different from IaaS cloud service. In case of IaaS cloud service, there is a service provider who rents. See the difference, please. In case of IaaS cloud service, there is a service provider, right? There is a service provider who rents the required infrastructure to the users. Whereas in grid computing, multiple computing nodes join together to solve a common computational problem. This is the basic difference between cloud computing and grid computing. To set up a grid by connecting numerous nodes in terms of data as well as CPU, a middleware is required to implement the distributed processor architecture. The Globus toolkit, can you please note down it. The Globus toolkit is one such software toolkit used for building grids, right? There being any MCQ type question, name the toolkit which will used for building grids, and it is open source, right? It is also open source. The highlighted parts are very important in this chapter. Please go through all these things. It includes software for security, resource management, data management, communication, fault detection, etc. So all this is about grid computing. So today we have learned cloud computing, grid computing, difference between cloud computing and grid computing, and here comes blockchains. I will discuss the next part in the next class, right? Thank you for watching, and please, if you have any query, ask me, comment me. I will definitely clarify your all your doubts. Thank you.